Okie doke. Welcome to our quiz review for logarithm properties. Welcome to my live audience and those of you at home. All right, here we go. So our first one, there'll be a question similar to this where we have a true or false. Again, if you have a Desmos calculator, you could just type in your log base 2 of 5 and see if that's true or false. But let's think about what this represents again. Remember, this is your 2, your base, so the 1.7 equals 5. So one thing to think about is you guys know what 2 to the first power is. That's 2. 2 to the second power is 4. And 2 to the third power is 8. So if we know that we have 2 to the 1.7, that's going to be somewhere between here and here. Well, 5 is not in between 2 and 4. So even without a calculator, hopefully you could use some reasoning with the rewriting it as an exponential. This equation over here, when you pick 2 to the 1.7, it's going to be between 2 and 4. And 5 is not that. So this one would be false. You could always check it and see what 2 to the 1.7 is. Okay. All right, next. Now we want to expand this and rewrite it as a different form with longer, kind of a drawn out form. So remember, when you have multiplication, that means you're going to be adding. When you have the division, that means you're going to be dividing. So let's take a look here what this would look at. We always will write that base 4. It kind of gets tedious here. I've got log base 4 of m squared plus log base 4 of p minus log base 4 of r cubed. That just highlights that multiplication of the terms inside the log are addition of their separate pieces, and then of course division is subtraction. Now we can simplify this a little bit further. So if I have this power up front and I want to drag that out, the power up top, he can come out front. That's the power property of logs. So 2 log base 4 of m plus, this one is all done, log base 4 of p, it's just all by itself. You can't make that a different number. There's no exponent. And then finally, this one subtract. We're going to bring this 3 down out front as well, because the power property says if it's an exponent, you can bring them out front. So that would be our expanded form of the original. And you'd be done. All right, the next one. Okay, so here we want to rewrite this and look at what other form it could be in. And so we have a number out front, which means we could put it back in the power. I'm going to take this 3 and realize if you have the multiplication up front, that could go back up to the power. And so I could rewrite this as log base 5 of 4 to the third. And then even to make that even prettier, that could be rewritten as log base 5. And you could multiply 4 times 4 times 4, which I believe 64. Hope that's right. There we go. So just make sure you can rewrite these using that rule. A lot of times you aren't solving anything with these properties. You're just rewriting them in a different form. And on the quiz, there'll be some matching. And this is kind of where this one's being pulled from, where if you can recognize this original black equation, or sorry, black expression rewritten as this guy, that would be your comparison. You'd match them. Could you check it on a calculator? That's a resource. Okay. All right, let's rewrite, see what this one could be rewritten as using our properties. So I see this addition, which means I could rewrite these terms as a multiplication with the same base. So I'd have log base 2. And instead of addition, I'd have 5 times 3. Just rewrite it as one term. So of course our final answer could be log base 2 of 15. And again, if you could recognize that green final solution is the same as this first one, or check it on a calculator, you're good to go. I'm just using those properties, different forms. Oops, sorry. Okay, here we go. Let's try this one. Rewriting this guy as a different form. Remember the number out front could go back up and be a power. So we could rewrite this as log base 3 of 7 squared, which of course could be log base 3 of 49. And that right there is enough, but you know I've looked at the quiz, and one thing to think about is the change of base formula. And this was the last one on the video I did for your instructions, or the last day of your one of the last days of your packet before you reviewed. If you don't have a calculator with base 3, like the TI calculators don't have the base 3, we have to use Desmos. One way to do this, here was the rule we had. It said log base b of a could be rewritten as log of a over log of b. And that's the property. That's the change of base rule. So again, if you ever would see something like, if I put an arrow here, log 49 over log 3, that would be another way. All of these are the exact same thing. You could check it with a calculator, but that would be another way to rewrite this original black one. Kind of crazy how there's 4 different colors there, 4 different ways to rewrite that original, or 3 different ways, I guess. One thing with this change of base formula up here, I think this little B down here is base. I think of basement, and that's why I always remember he's in the bottom. So when you're doing the fraction, you're like, which of these numbers, does the 49 or the 3 go in the bottom? The B is the base. It's in the basement. He will stay in the basement over there. So if you ever want something to remember it, that's when I do it. All right, we're almost done here. Let's look at this guy. They will ask you to calculate this exactly and in a decimal approximation. So you could kind of think about guessing it. You could say, well, gosh, I know 3 to the first power is 3, or 3 to the second power is 9, and of course 3 to the third power is 27. You could now note that this power is going to be somewhere between 2 and 3, and probably pretty darn close to 2. So you could estimate it in your head. You could play with it on a calculator if you wanted to. But I'll show you how you can, and you could get it with the exact answer, play with the calculator. But remember how we can rewrite this with logs? That would say log base 3 of 10 equals x. This goes back to you rewriting an exponential function as a log function, those inverses of each other. So if you had a Desmos ability, you could just type this guy into Desmos. And so you could do that if you want to. But let's say you don't have Desmos, you could use that change of base formula that we just went over, which would mean this is log 10. Remember, we don't see a number, a little tiny base number there, it's base 10. And then we could write that over log 3. Notice how your 3 is still in the basement. This would be that same answer. Now, I actually need to type that in on my calculator here. So if I take log 10 divided by log 3, I get 2.096, I'll say. All right, so this would be a decimal approximated answer, and this would be your exact answer. So I'll write that by here. This is your exact answer, and this would be your decimal approximation. A lot of us prefer the decimal one, and it makes sense. It is close to that 2, like I thought it would be, very close to that 2, but the exact answer is important if you're working for NASA, let's say. So keep that in mind. All right, and then finally, here we have an expanded form of logs, and we could rewrite this as a more condensed version. So again, if there's a number out front, it can always go up and be the power. I've got 2 of these numbers out front. I can put them back as the power. And then if I see the addition sign, that means I could do multiplication of those components together. So I'm going to first rewrite this as log of 9 to the 1/2. And I'm going to actually leave it as a plus for a second. Log of m to the 5th power. So that's just dealing with that exponent got pulled out front with our power property of logs. But now we know that when you're doing addition, you can rewrite these separate terms times each other and just do log once. So I'd have log of 9 to the half times m to the fifth. And I picked this 9 because 9 to the half, remember when it's to a half power, it's actually the power over the root. So this is actually the square root of 9, which we know to be 3. And you could use a calculator for that as well. So my final answer would be log of 3m to the fifth. This would be my condensed version of my original expanded log expression. So those right there should get you through the decent portions of the quiz. The quiz itself is 6 questions. One of them is matching, and 2 of them are multiple choice. And then the other ones just have you rewrite, basically rewriting either an expanded or a condensed version. And did I say 2 are multiple choice? I meant 3. So 3 multiple choice and 1 matching, and then 2 just kind of condensed. All right, so that's the end of your quiz review. That'll be posted on Wednesday, this Wednesday, May 6th, as a PDF form and plan book. And then it will be on the Google Classroom as well through Edulastic up until the 11th at 11:55. Good luck.